b times 20 equals 0. What does b have to be?
0.
If I have a times 0, well, I don't like that one. But with both of these, whenever we have two things that are being multiplied, at least one of the things has to be what? 0. You also have the option of both of them being 0. Both of them can be 0. So there is something called the zero product property that says if the product of two or more factors equals 0, then at least one of the factors must also equal 0. Okay? And we actually use the zero product property when we're solving by factoring. Okay? And I'll tell you when we kind of start using that. But we're going to go ahead and start solving by factoring. So in many cases, we find the solutions of a quadratic equation by factoring rather than graphing. Follow the steps below to find the solutions of the given equation by factoring. So we're going to start with this. We have to first set our quadratic equation equal to 0. So we're going to do 2x squared plus 5x minus 3 equals 0. We are going to start by setting it equal to 0. Because we are trying to find the solution. We are trying to find the zeros. We're trying to find what makes it equal 0. So if we start here, and I'm going to look at this, the first thing we always check for factoring is there a greatest common factor? Does that have a GCF? No. Okay, so if it doesn't have a GCF, we automatically look, is it 2 terms or 3 terms? 3 terms. Since it is 3 terms, can we use the shortcut for this one?
No.
Why can I not use the shortcut? Because a is not 1, right? So we have to do this the longer way, where we have to factor it by grouping. So we're going to have to figure out what multiplies to give us our a times c. What is a times c? And we have to figure out what adds to give us our b term. What is our b term? What multiplies to give you -6 but adds to give you +5? 6 and -1. So we use these to rewrite our middle term here. So we have 2x squared plus 6x minus 1x minus 3 equals 0. Now we solve by grouping. Okay, so we factor this by grouping. We're going to group the first two together. Do those have a greatest common factor?
Yes.
What? If we take out a 2x, what does that leave us with? Then if we look at this second 2, do those two have a greatest common factor?
-1.
It is -1. So if we factor out a -1, what does that leave us with? And it still all is equal to 0. What part is the same? Then we have what's left over. Equals 0. So now we have our answer, or our equation in factored form, right? This is where the zero product property comes in. I have two things that are multiplied together and equal 0. What does that mean? One or both of them must be 0. So what we do is we take each of these and we set them equal to 0 and solve. How would I solve x plus 3 equals 0? Or subtract 3 on both sides. So x is equal to -3. Then we're going to do the same thing for this. So we're going to do 2x minus 1 equals 0. What do I do from there? It's already negative, so we need to plus 1. So we have 2x is equal to 1. Then what? Divide by 2. X is equal to 1/2. And then just like we did with solving by graphing, we're going to write our solution as a solution set, which just means we're going to do a list of our solutions, starting with the smallest and ending in the biggest. Which one do I need to put first? So -3, 1/3. So the reason those are our solutions, okay, is if I plugged either of these into this equation, it's going to give me 0. So let's try it out. What is -3 squared? 9. What is 9 times 2? 18. So this first term here is 18. What is 5 times -3? So what is 18 minus 15 minus 3? 0. Okay, so that one checks out. If we did 1/2, what happens if you square 1/2? It's 1/4. So that is technically 1/4 times 2 is 1/2. So this is all 1/2 plus 5/2 minus 3. So 1/2 plus 5/2 is 6/2. What is 6/2 the same as? 3. What is 3 minus 3? 0. So both of those create zeros in the function, right? That's why there are solutions, because they make the whole equation equal 0. So that is how we find our answers by factoring. We factor, set both factors equal to 0, and solve, okay? Now, that is the longest type of factoring problem we can have. A lot of times they don't end up being that long. So let's go ahead and look at several of these examples. We're going to do all of the evens together with a couple of the odds sprinkled in that are specific types of examples. So I want us to start with number 2. So for number 2, does that trinomial have a greatest common factor? No. How many terms is it? 3. Okay. Can I use the shortcut? Why can I use the shortcut for this one? Because A is 1. So when we set this up and do what times what gives us A times C, what is A times C? Because we do A term times our C term. And we have to figure out what multiplies to give us that and what adds to give us B. What is our B? What multiplies to give you positive 21 but adds to give you negative 21? Negative 7, negative 3. Okay, we can use the shortcut, right? So we can just jump straight to our factors. X minus 7 times x minus 3 equals 0. And now we're going to take the first one and set that equal to 0. So we're going to do x minus 7 equals 0. How do I solve that? So our first one gives us x is 7. Then we're going to look at the second one here. So I need to do x minus 3 equals 0. How do I solve that? Which is x is equal to 3. So for us to write our solution, use a curly bracket so we can write as a solution set. And we're going to go 3, 7. And if I plugged any of those in, it's going to give us, yes. We're factoring. So what we learned in Unit 7, that's what we're doing. We're factoring it to get it to our factored form. Once we get it to factored form, we're using the zero products property to set them both equal to 0. And when we solve those, it gives us our solutions to the quadratic.
Where the x come from? The first one?
This? Well, what squares to give you x squared?
Okay. Okay. So that, okay.
We're doing the same strategies we did 2 units ago. Y'all are going to notice that as we're going through this unit, as we're going through 9.2 specifically, I'm not going to sit here and go through all of the factoring in super deep detail because we spent a whole unit on it. We already took a test on it. If you suddenly cannot factor, but you did remarkably well on the Unit 7 test, I'm going to have some suspicion. So, just if you see me going through the factoring pretty quickly, it's because we already factored a lot. Yes?
Doesn't matter what do you put the 3 to 7 in?
It goes from smallest to biggest. Yeah. All right. Let's look at number 4. So for number 4, is there a greatest common factor there? Is there a 5 in all 3 of the terms though? No. Okay, but there is 3 terms. So can I use the shortcut?
Yes.
Why?
Because that's 1.
So we have to figure out what multiplies to give us A times C, which would be what? And figure out what adds to give us B, which is what multiplies to give you 25 but adds to give you 10? 5 and 5. So we can write our factors now as x plus 5 times x plus 5 equals 0. We could also write it as x plus 5 squared. Either way works. And now we're going to set them both equal to 0 and solve. So we're going to do x plus 5 equals 0. And we need to do x plus 5 equals 0. I have a question. Are those the same thing?
Yes.
Are they going to give you the same answer when you solve them? What is the answer they're going to give you?
-5.
Both of those will give you x equals -5. When I go to write our answer for this, do you think it's necessary for me to put -5 twice? No. We can just write x is -5.
Are you wrong if you put it twice?
You're not wrong if you put it twice. You're just being redundant. It's not necessary. But if you put it, I'm not going to count off for that because you're not wrong. All right. And this also makes sense when you write it like x plus 5 squared because it's only there one time. Yes. Yes. All right. So now we're going to go ahead and look at number 6. Okay, for number 6, does number 6 have a greatest common factor? What is the greatest common factor? 6x. If we take out a 6x, what does that leave us with?
X minus 2.
Equals 0. Now, can I factor either of those pieces any further?
No.
No. Okay, so we are ready to set this up. So we're going to start with the first one, and we're going to do 6x equals 0. How do I solve that?
0.
Yeah, but how would I solve it, though?
Oh.
Divide both sides by 6, and we get x equals 0. Then we're going to do the same thing for x minus 2. Set it equal to 0. How do I solve that? X equals 2. So we have our two solutions. How should I write those?
0, 2.
Since this one is just 2 terms, it's either going to have just a GCF or it could have a difference of squares. This one just has a GCF. This one doesn't have a difference of squares. And that's where our graphic organizer we did comes in handy. Okay? Because it tells us, first, look for your GCF. Okay? That's going to be the first step always, is check to see if there's a GCF. If you have checked for a GCF, you look, is it 2 terms? If it is 2 terms, you'll check it for a difference of squares, which means both are perfect squares. If it is 3 terms, it is a trinomial. So either you can use the shortcut because A is 1, or you cannot use the shortcut because A is not 1. Now we're going to go ahead and we're going to go to question 8. So for question 8, okay, does this have a greatest common factor?
No.
No. So how many terms is it?
2.
So what do we need to check it for? Okay, is that a difference of squares? Yeah, because perfect square, difference. So remember, for difference of squares, all we have to do, what squares to give you 4x squared? What squares to give you 81? And what signs do I need?
Plus or minus.
There we go. And then we take our pieces, set them equal to 0, and solve. So we're going to take the first piece, 2x plus 9 equals 0. How do I solve that? Minus 9 on both sides. So we get 2x equals -9. From there, what do we do? So we get x is equal to -9 over 2. Do what? Yes. Yes. Now we're going to take this one, and we're going to do 2x minus 9 equals 0. Now what do I do?
Plus 9.
So we get 2x equals 9. Then what? Divide everything by 2. So we get x equals 9 over 2. And we need to write our answer. Which one should I put first? comma, positive 9 over 2. Now, we're going to do a little bit of jumping around, just a smidgen. And we're going to do 9, 10, and 12. Okay, for number 9. Does that have a greatest common factor? What? 3. So let's take that out. When we take out that greatest common factor of 3, what does that leave us with? Okay. Now, this inside piece, can we factor that again? Yes. Can we use the shortcut when we factor it? All right, we can because A is 1. So I'm going to actually do this on this side. What multiplies? Remember, you could also organize it using the X Games way, which what multiplies to give you -4 but adds to give you 3? -1, +4. So we have X minus 1 times X plus 4. And we put equals 0. What did I forget to do, though? We took out a GCF. It's still got to come down. Okay. When we do that, now we have 3 things that are being multiplied together, right? So we're going to check all 3 to see what they are when they equal 0. So we're going to start with 3. Does 3 equal 0? No. Okay. Having a greatest common factor in front that is a number does not impact our answer. Okay? Yes, ma'am. Go ahead. Because that A in front is just our vertical stretch, right? Chadi, Swain, stand up for a second. Both of you. Okay. What is the main difference between the two of them? Their height, right? Okay. This same thing can happen with quadratics. Okay? So, they're both in my 5th period algebra class. They both have dark hair. So, they have the same solutions for that. Okay? So, if we're looking at a graph, the solutions would be the same. Now, Chadi is a normal size parabola. Okay? But Swain got multiplied by 3. And so Swain is a taller parabola that has been stretched out. Okay? That is all putting that greatest common, y'all can sit down now. That is all putting that greatest common factor in 3 causes to happen. Is it just causes the graph to get a little more stretched out. It's not changing the locations of the solutions. All it is just stretching you out just a little bit. Does that make sense? Okay? So we can't just pretend the greatest common factor doesn't exist. Because it does exist and it impacts what the graph looks like. But it doesn't impact the solution. If that makes sense. You're still in my 5th period Algebra 1 class. Your height doesn't really matter, right? That's the difference with the GCF. Your solution, you're still here, but the height is different.
So it doesn't go anywhere near your solution.
It doesn't go in your solution because it's not impacting that. But it is impacting what the shape of the graph looks like. Okay, so then we're going to put in x minus 1 equals 0. Can I solve that? Yeah. Add 1 to both sides. X equals 1. Take our x plus 4 equals 0. Can I solve that? Yeah. Minus 4 on both sides. X equals -4. So when it can be solved, it impacts your solution. But this doesn't because it's not true. Okay? So that is why it's important. We have to keep our greatest common factor in the problem because otherwise we're not showing what the graph actually is. But it isn't part of our solution. X equals -4 and 1. All right. The last couple examples. Let's see. Yeah. Okay. We're going to do number 10 together as well. So, for number 10, can I take out a greatest common factor? No. Can I use the shortcut? No. Okay, so we got to set it up and do it by grouping. So to factor by grouping, you had to figure out what multiplies to give you A times C. What is A times C? And we had to figure out what adds to give us B. What is our B? What multiplies to give you negative 10, but adds to give you 3? Negative 2, positive 5. And so we said we can't use the shortcut here. So we're going to do 2x squared. Then we're going to rewrite this 3x term using our two new factors. Minus 2x plus 5x minus 5 equals 0. And we're going to group first two, last two. When we group the first two, what is their greatest common factor? Okay, so if we take out a 2x, what does that leave us with? X minus 1. Okay, for the second two, what is their greatest common factor? If we take that out, what does that leave us with? All right, from here, what part's the same? What part's left over? So there's our factored form. And now we had to find our solution. So I want you all to take it from here and find the solutions. We all have a case of the sniffles, it sounds like. From all over the room, I'm just hearing. No, it's like 3 people, I think. But I think it is mostly him. It'll go first because it's negative. If it was positive 5 over 2, yeah. But since it's negative, it goes after. Yes. Yes. All right. You can. As soon as she gets back. Or as soon as Ava gets back. Go when Ava gets back. Then, yeah, perfect. All right. So what should our solutions be? Negative 5 over 2 and 1. Huh? Yes. Unless both are negative. All right. Now, we're going to go ahead and look at number 12. Okay? Number 12 is the last one we're going to do all together. So let's go ahead and look at number 12. So, is there a greatest common factor here? What? Okay. What does that leave us with? Now, inside of there, we have a trinomial. So, that we could use the shortcut on. So, let's figure it out. What is our A times C? What is our B? Is there 2 numbers that multiply to give you 1, but add to give you negative 4?
I don't feel like there is.
There's not. Okay, so this right here is prime. Okay, so if you ever have something that is prime, it doesn't necessarily mean it doesn't have a solution. It just means you can't find the solution by factoring. Can't solve by factoring. Which, that is where all the other methods come into play. Because like I said, there's some types of problems that the different methods are better for solving. It just depends on what that is and what the properties are. And we'll talk about how to recognize different types and when to do what. The last lesson of this unit is literally about finding the best method. Because there's ways that you can do less work by choosing the best method. Okay? But we're going to go ahead and I want us to do all of the odds that we haven't done so far. So 1, 3, 5, 7, and 11. I want us to do those 5 questions. a little bit. A very happy face because it's like, but yes.